All right, so today we are going to be writing equations of quadratic functions using vertices, points, and x-intercepts. We also want to be able to write quadratic equations to model data sets. When you see this word model, it means that you're going to be coming up with regression equations. That means you could have a line of best fit, or you can even have a parabola of best fit. We'll be getting to that last. For now, we need to understand what average rate of change means. It's the same thing as slope. I'm going to write the slope, but it's going to look different from what you're used to. You guys are used to seeing x sub 1, y sub 1, x sub 2, y sub 2. You're used to your slope formula being y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But what have I been saying that f of x means? Y. So this means the same thing. You have to make the jump to what we call function notation. When you see f of x sub 2, that just means plugging in the second x into the function. Alright? It still means the second y. Let's look at this first example. Find the average rate of change over -1 to 1. Well, what that means then is I need to know the points. At -1, what is my y value? 0. At +1, what is the y value? -2. So if I want to find the average rate of change over this interval, see, it's always changing as I go from -1 to 1, and we're asking what's the average of that change. So now we're just going to find the slope. We're doing f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. We get -2 over 2, and so that is -1. So does it appear that as we go from here to here, that slope is -1? Are we going down 2 over 2? Yeah, so that is correct. That's our average rate of change, same as slope. All right, look at what this says now. What do you think f of 2 means? Right, when x is 2, what is y? Looking at this picture, what is y when x is 2? 0. So this is asking us, what is 0 minus, and now what's f of 1? Good. And then over 2 minus 1, and so that's going to just be 2. So that's telling me the average rate of change from x equals 1 to x equals 2. Can you see how we go up 2 over 1? So that would be correct there. Average rate of change is just slope. Now, what is the distance from f of 1 to f of 2? Here's f of 1 right here. Here's f of 2 right here. I want to know the distance. Well, I can just create a triangle here. Can you see that triangle I'm creating? I'll redraw it down here. What is this right here going to be? 1. What is this going to be? 2. How do I find that? Right. And so now we're going to have this. So the exact answer for that distance is radical 5. That's the exact answer. If you're asked for the approximate answer, we'd have to use a calculator, and we would do the square root of 5, and it's 2.24 to the nearest hundredth. So approximately 2.24. All right? What else could I have used to find the distance between these points of 1, -2, and 2, 0? What else could I have used? Distance formula. So look what would have happened, guys. I would have done 1 minus 2 squared, so that would be -1 squared, which is 1. I would have done -2 minus 0, which is -2 squared, which is 4. Can you see how I'd get the same answer? Okay. All right, down here. Yes, Sarah?
I'm confused on the find the average rate of change over
this one?
Yeah.
Okay, so what I had to do was find the point. So when x is -1, y was 0. and then I had to go to positive 1. So when x is positive 1, y is negative 2. And then I just know that average rate of change means slope, so I'm really just finding the slope between those 2 points. That's what average rate of change means, is slope.
And then can you explain the second part too?
Okay, so on the second part, it's asking me, what is y when x is 2? So I go to 2, and y is 0. And then it says subtract, and then this is saying, what is y when x is 1? And that's going to be negative 2. So this is really telling me to do 0 minus negative 2, and 2 minus 1 is just 1. So it's 2. Okay? Any other questions? All right, let's go down here. Review. Given a point in a vertex, this is our vertex form. Given a point in the x-intercepts, this is our form for intercept form. If I'm given 3 or more points, I'm going to have to use the calculator in quadratic regression. We're going to have 3 different methods for finding quadratic equations. You also want to remember, when you see this a, that's the same thing as 1 over 4p, where p is the distance from vertex to focus, or vertex to what? Directrix. Okay? So if they tell us the distance from the vertex to the focus, we can plug that value in for p if necessary. But a lot of times we're just going to be finding a. So what we're going to look at next is we're going to be given some information and we have to come up with the equation. Let's look at this example. So they're telling us that the parabola, well actually right here first. Write an equation of the parabola in vertex form. So because I know this vertex, I'm going to do the y equals a times x minus h squared plus k. Questions on how I got that? So now I'm going to have to find another point. Here's another point that I have not used. I'm going to have to plug in 4 for x and 6 for y. Why would I want to do that? What is it I need to know? A. I need to know A. I don't want the slope. A is not truly the slope. It's 1 over 4p, and I don't have enough information to find p. So what I'm going to have to do to find A is I'm going to have to plug in 6 for y. A I don't know. When y is 6, x is 4. Minus 2. So evaluating this, I have 6 equals 4 minus 2 is 2, squared is 4, so I have 4a minus 2. And so now I'm going to have 4a equals 8, and so what's a going to be? 2. Lots of 2's in this problem. So now I can write my equation. Y equals, here's my a value, 2. X minus 2 squared minus 2. That would be the equation that would have this vertex and pass through that point. Okay? That's a little bit new from what we've done. Alright, this is the same kind of problem, exactly the same kind. Let's go ahead and get it started. How do we start it? Y equals a times what? X plus 2 squared, and then what? Plus 5. Okay. So once we have that, we're going to want to find out what A is. So what do I do to find A? Plug in the other point, right? I can't use, what would happen, do you think, if I use this point again? I get 0 equals 0 is all that would happen. I couldn't solve it. So I need to plug this in. 7 is y, here's x, here's y, here's h, here's k. So 7 is y, a I don't know, x is -4 plus 5. Okay, don't write down the rest of it, just watch. 7 equals, -2 squared is 4, 4a plus 5. So I'm going to get 4a equals 2, a equals 1/2. So now it's going to be y equals, put in the a, x plus 2 squared plus 5. Do you understand the process there? Who said no?
I don't understand, like, on that, from the second to third step.
Second to third step, I did -4 plus 2 is -2 squared is 4. A plus 5 equals 7. Alright, you can go back and watch that if you need to. Write an equation of the parabola and intercept form. These two are exactly alike. We're just going to do one of them. Let's just go ahead and do this one. So I have an x-intercept of 7 and I have an x-intercept of 10, and I have to pass through this point. If this is an x-intercept, this is going to be the p value, this is going to be the q value. So the equation I'm going to use is this one right here. Okay? So it's going to have to go y equals a times x minus 7 times x minus 10. Do you get why I did that? Because I have p and q. What would you think I would do now if I have to find a? Kylie? Very good. All I'm doing is plugging in x and y. Okay? So solving this, I'm going to have 27 equals, this is -9, this is -12. -9 times -12, isn't that 108? So I'm going to have 108a. So a then is going to be 27 over 108. I want to write that as a fraction in lowest terms. So I'm going to use my calculator, 27 divided by 108. Get that answer, and then math, frac, you already know that of course, is 1/4. So then I know it's going to be, going back up to here, because now I know what a is. Y equals a x minus p times x minus q. So all I have to do is figure out what a is by plugging in x and y back here. And then I can write the equation. Kind of cool side note, don't try to do this with me, I'm just going to do it really quick. If I put in this, what I should see when I check my table is I should see that point that it's supposed to pass through, right? So when I go to my table, I should see this point of -227. And look, right there it is, -227. See how I can see the point 70? I can see the point 10. So therefore I know that this is correct. Okay? Alright, determining the data model given a set of evenly spaced inputs. Inputs are x's. So as long as my x's are evenly spaced, if the first differences of the outputs, meaning the y's, are the same, then the function is linear. If the second differences of the outputs, meaning the y's, are the same, then the function is quadratic. Third difference is the same, then it's cubic, etc. Let me show you what we mean by this. Looking at these examples, first I check on number 5. Are the inputs evenly spaced? Yeah. So now I need to find these differences. 424 to 416, that is down 8. 416 to 376, that's down 40. This is down 72. This is down 104. This is down 136. That's what we call our first differences. All I'm saying is, what do I do to this to get that? What do I do to this to get that? Those are called first differences. Are they all the same number? No, so this is not linear. Go to second differences. What do I do to negative 8 to get negative 40? Subtract 32. That would be subtract 32. That's subtract 32, and that's subtract 32. So yay, second differences are all the same. So what does that mean about this data? It must be quadratic. So now we have to find that quadratic equation. Go to your home screen, clear everything out. Go to Stat, Edit. I go up to the very top, I clear. Go up to the very top and clear. Put in your X's. In L2, we put in our Y's. Alright, so I have them all put in. I like to see the points. You do not have to see the points to do this though. Okay? I don't have to see the points. I could right now just go to Stat, Calculate. Which one did we say this is? Quadratic. Go to Quadratic. Go down here to Calculate. I'm showing just the very basic that you need to do. R squared is 1 is perfectly quadratic, so this has to be y equals ax squared plus bx plus c. So it must be y equals negative 16x squared plus 40x plus 400. That's the equation. Alright? Make sense? That's the basic that we could do. Let's look at the next one now. Check out your inputs. They're all evenly spaced. Tell me what my first difference is here. Negative 6. Negative 6. Negative 6. Is that negative 6? Yeah. Negative 6 and negative 6. Okay, so what's this going to be? Linear. Do the exact same thing, but push the button linear. We're not going to do that whole thing. Looking at number 7, evenly spaced. This is up 10, up 30, 90. Use a calculator. Thank you. And this is 810. Is that 810? I believe so. Checking my second differences. This is 20. This is 60. This is 280. This is 40. Thanks. Thank you. Okay, 270 then to 810. Thanks. Okay, so is it linear? No. Is it quadratic? No. One more check. This would be up 40. My next one would be up 120. Is it even cubic? No. So we're going to stop there. It's something else. Nothing that we can get easily, so we're not going to worry about it. Number 8. The table shows a university's budget in millions of dollars over a 10-year period where x equals 0 represents the first year in a 10-year period. Here are the years, here's the budget. Use a graphing calculator to create a scatter plot. Go to Stat, Edit. I want to remind you how to do a scatter plot. Put in these numbers. Now I could find those differences if I wanted, but it's asking me to just do a scatter plot to see it because it may not be exact. So I have to see these points. So I'm going to have to turn on my stat plots. Two ways to do it. I can go to y equals and I can go right up here and push enter. That's the fastest way to turn on your stat plots. Everybody see that? Y equals, arrow up. If that's highlighted, the stat plots are on. So we have our stat plots on, we have our data in, so I'm going to do a zoom what? Zoom stat. Here's the way it looks. Is that quadratic? It looks like quadratic would be the best fit for it. It's definitely not linear, is it? So we say quadratic is probably going to be the best. So now we're going to go to stat, calculate. We go down to quadratic. Let's do the extra step. Do you guys remember how I can get it to put the equation in there for me? I go to vars, y vars, function, y sub 1, calculate, enter, and it tells me what it is. And you can see it's not great. It's not a great representation, but it's above 0.8, so it's good enough. I'm going to hit graph, and there's the quadratic that goes best fits that all those data points. It's not going to look perfect, okay? So it says a line or parabola. So parabola is best. Explain, we looked at it, we're not going to explain. Use the regression feature to find the model. So now I'm not going to write all this out, guys. That would be absolutely ridiculous. So I'm going to go back and I'm going to look at that one more time. I just want to round it to the nearest hundredth. So I'm going to have y equals 1.49 x squared plus 0.51x plus 39.98. Now, I'd like for you though to keep this in here because this is a better representation, isn't it? Because this one I rounded. Use the model in part B to predict when the budget of the university is $500 million. This represents $150 million here after 10 years. Okay, so it's going to be a lot more than 10 years, isn't it? Here's what I can do. Go down into y sub 2. What am I going to put? Am I going to put 500 million? No. What am I going to put? 500. I want to know, why is 500? I really could solve it by putting 500 into my equation. So what I'm doing is I'm putting this in for y, and I'm going to look at the graph. Do you notice how I can't see y equals 500? I have to go to window on my own, and I'm going to have to make this y max so that it's bigger than 500. I'm going to make it 550. Now hit graph. There's the parabola. There's y equals 500. Can I see where they're going to intersect? So I have to go back to window. It's out there a lot further in the x direction. I'm going to have to make this maybe 50 just to be sure. Yeah, it's going to condense everything in there real tight with the points. Okay, so there's the point. Here's how you do that. This might be new for some of you. Second trace, calculate intersection. Get close.
Where's the tree? Oh, yeah.
Hold on, and I'll help you individually, but I need to be able to see that point, and I'm looking at my y's. I want to get it close to 500 on my y's. There it is, close to 500. I'm just arrowing left and right until I get it, the y to say close to 500. Then I push enter, and now it's saying, is this the second line? I push enter and enter one more time, and it's 17.4. 17.4 years from now is when the budget would be 500 million. The other way I could do this would be to look at my table, and I'm looking for when y sub 1 is 500. Can you see how it's close in between 17 and 18? It's going to be close, so I could know that it should be in between 17 and 18 years. Okay? All right, guys.